Teaching individuals who are severely visually impaired or blind is the job of rehabilitation and special education professionals, such as rehabilitation teachers, mobility instructors, and teachers of visually impaired children. The skills they teach relate to everyday tasks like reading, writing, doing arithmetic, preparing food, caring for personal and household needs, and traveling. Teaching an individual who is blind or visually impaired might at first glance appear to be a difficult task. However, if the instructor is aware of the problems inherent in communicating with students who have limited or no vision, and she knows the methods used to overcome such barriers, the teaching is little different than it is with any learner. The purpose of this videotape is to identify the communication barriers and to describe techniques for enhancing instructional communication with learners who are blind or visually impaired.
The square knot that's used in macrame.
In order to understand the basic problem, one must first realize that there is a verbal and a nonverbal component to instructional communication. For example, as an instructor explains the process of tying the square knot to most learners, he also demonstrates the movements required to complete the task.
And then through this loop, and then it's tightened up. And then the second knot, the second half of the knot is the same, only it changes sides. Under, over, and through, like so. And then it remains kind of square like it did. Go ahead and, do you understand by watching it?
Yeah.
Okay. I need to reach in here and look. Sure is, great. All right.
Similarly, a classroom lecturer enhances complex explanations with visual aids, such as pictures, graphs, or scale models. Lecturers also commonly use gestures, such as pointing, and use accompanying phrases like over there and that one. If the learner is visually impaired and is not able to see these aids and gestures, much of the information being presented is lost. An inexperienced instructor who is faced with introducing a new device to someone with limited or no vision would naturally attempt to describe it in greater detail. If the object being described is simple, this method works well. However, words alone are inadequate when describing visually complex items. For example, compare the mental image you get from the following description of a ceramic pot to how it actually looks.
Okay, I'm describing a ceramic pot. The pot has a face on the front side of it. The eyes and the nose part is three-dimensional. It has a beard, and that's kind of painted on the side. It has a ledge that goes all the way around the top of it with 4 holes. There's kind of like a stopper or a cap on top that's made out of bark. And the whole thing is blue except for the face where that's kind of a tannish flesh color.
Since the verbal part of instruction is sometimes difficult, a nonverbal component is often required. Therefore, the instructor needs not only to understand the methods for enhancing verbal instruction, but also for presenting the nonverbal part in a way that can be understood by individuals with severe visual impairments.
1, 2, and 3. The y-axis is labeled 1, 2, 3, 4, and 5.
It is relatively easy to overcome the communication barriers caused by visual impairment by using one of the following methods: using precise language, using analogies, using auditory cues, giving the learner more descriptive responsibility, using tactual modeling demonstrations, presenting tactual or highly visible scale models, and manipulating learner movements. Using such terms as there, here, thing, and stuff should be avoided.
Pick it up.
specific names of items like computer components or tape recorders and their parts, and a precise description of the steps required in the performance of a skill should be used. Note the language used in this tape recorder
How
lesson.
many buttons? Tracy, now that you've taken a look at this as a whole, let's go back over these individual parts, and I'll tell you their names, and then in a few minutes we'll start working on the functions of each.
All right.
You remember the keyboard,
Yes,
and how many keys again?
there's 6 of them.
Okay. And you said that they had individual markings, so why don't you describe what they are, and I'll tell you which key it is, since I know you already are familiar with other kinds of tape recorders.
Okay, the first one has a X on it.
Okay. That one is simply the off switch, or the one that if you push it, you'll find out what it does. Go ahead.
Okay, the cassette door just opened.
All right, so that's the stop eject button, we'll call it.
Mm-hmm.
All right.
And then the next one has a single line on it.
Mm-hmm. And depress it. Nothing happens.
Nothing.
Do you have a pause button, or do you know what a pause button is?
Yes.
Okay, that's what it is. So depressed it would be,
Then the pause would be on.
that's right.
Okay, now I just shut it off.
So that's the pause button.
The next one has a circle marking on it.
Yep, you might as well turn it on to see what it is. All
It's playing.
right. Yep. So it's the play button, obviously. And shut it off.
Okay.
With the what button?
This is the stop button with the X.
Okay.
Assuming that the learner is not a very young child, analogies can help clarify explanations and descriptions. For example, while explaining the function of a computer disk, the instructor might compare it with an audio cassette or a compact disc.
Put it onto to some permanent storage place. In a computer, that's a computer disk, and take a look at that. That disk, I assume that you've used tape recorders and record players and those kinds of things. And,
Yeah.
this is very much the same. It's only instead of storing words like those things do, this stores the electronic signals that you typed into the computer, so that when you give it this, pardon me?
I said, huh, it's amazing.
So when you give it this command called save, then it will save automatically, or if you will, record onto that disk drive, and then you can carry it around in your pocket just like you could a cassette tape. And when you put it back in this machine, you can then do this operation called retrieve and have it back in front of your eyes again and back working on it.
It's relatively easy for most people to locate the direction of a sound. Therefore, auditory cues can be used in giving instruction. For example, in telling a person who is blind how to get to a specific location, it's simple for the instructor to go to the desired location and give an auditory cue.
Okay, Vernon. Now that we're done doing dishes the easy way, we're going to go to the sink and do them the hard way. Sometimes, instead of me trying to describe to you how to get there, it's easier for me to go to the sink and then simply say, over here it is. So why don't you come ahead? Okay. Phil, I know you've told me that you have used talking calculators in the past. I thought I'd show you this one. It's relatively new.
It's difficult or impossible for an individual with a visual impairment to see the gestures made by the instructor, but it's not difficult for the instructor to understand the student's gestures. Therefore, the communication problem can be avoided by having the learner rather than the teacher provide the description of a device to be learned. For instance, the instructor can have a student tactually or visually investigate items such as tape recorders or talking calculators and describe their parts as they are discovered. Thus, the teacher can avoid the awkwardness of trying to direct the student's movements verbally.
Point equal 7894561 2.
Just to tell you, it's the voice. It also has an on-off voice on-off switch.
Time minus plus divided by percent 100 100 memory 0 memory minus.
Okay, so it's got a place for storage and storage of numbers.
Yep. That's the
Clear.
That's the memory, right?
Mm-hmm.
What else do you find on the keyboard?
Memory clear. Memory plus. All clear.
Okay, looks like there's a slider switch at the top of the number pad. I don't know what this is for.
Yep. Let's try it out and
5.
push it a little ways. And
5.
there you go.
Sounds like it's switching the volume.
Mm-hmm. Yeah.
If the instructor is teaching a movement that is required to do a particular task, modeling can be used in much the same way it is when teaching learners with good vision.
Meaning that I'm going to show you the movement and you can follow it tactually and see how it's done. It's not too difficult. If you've got a hold of my wrist here, and I think if you grab the blade of the spatula, it works simply by rotating my wrist. So if I want to turn a sandwich... or
Note how the
anything, I
instructor
simply
is
put
demonstrating
this
the
under,
use of a
and
spatula
flip it
in this food preparation lesson.
like so.
Also, note how the student is tactually following the instructor's hand while the spatula is being rotated.
Oh, good, good. That's it. That's it. If you're then going to turn the sandwich that we have in front of us, what would you do?
Slide the spatula under the sandwich.
All right. And good, good, really good. Let me show you a model, a kind of enlarged kind of model we made out of cardboard here that may explain it.
Okay.
That's right.
In the same way, a scale model of a molecule
In
helps the
essence,
biology
one of the
teacher,
windows
an enlarged
that
model
we
of
have
something
the
too small to
stylus in
feel
the
or
video.
see with limited vision can be
Those-
helpful.
Well,
For
that's
example,
what-
the Braille cell window of a
Looks like
slate
it's got
is too small for many people to
outside.
tactually explore,
Appears to
but
be
an
a
enlarged
rectangle.
cardboard model can give the student a better understanding of how the
those-
Braille
those
slate
notches
window
are the same
actually
ones that You
looks.
should be able to find inside of each of those windows with the slate. So why don't we, once you get the stylus again now and stick it down the windows, run it down along the right edge of the window and see if you can then feel these little notches.
Yeah, I think I do.
Enlarged
Yesterday, when
models
you were
can
saying
also
you'd
be
like to do
used
macrame,
to show the individual steps in a
last night I made
complex
some
task,
models
such as
of,
tying a knot.
The way
Note
you
the
tie a
series of
macrame
models
knot.
used in this
And
lesson
there's
on
3 steps
macrame.
here, and I kind of hung them up on the wall here. If you want to just go ahead and take a look with your hands.
Okay. Okay, there's, what, 4 ropes?
Yeah.
Okay, it looks like the rope on the right, you go under the 2 in the middle, and it goes over the far left.
Right.
Okay.
Good.
There are occasionally times when it's necessary to actually manipulate the student's movements in order to make the action understood. This is generally considered the least favorable instructional method because it is somewhat intrusive. If manipulation is required, be sure to ask permission first. Note how the technique is used in this discus throwing lesson.
All right. Then come up, catch it in your hand. So it's going to be 1, 2, and then on the third, you're going to get this hand out of the way and let it fly.
As you watch the following examples of the 7 techniques described in this video, think of how they might be used in your own teaching situation.
First step, then my second step is my planting step, and see my shoulders turn and my back to the mat, then I spring and into the mat, so that we go step, plant, into the mat. Think it again. Step, plant, into the mat.
One of the ways that we orient people to large areas that they're not familiar with is by equating the area to a Braille cell. And if I'm not mistaken, you know Braille, correct? And you know about how the 6 dots are positioned in the Braille cell?
Yes.
Hit me with it if you would, please.
Yeah, dots 1, 2, and 3
Yep.
on the left, and 4, 5, and 6 on the right.
Okay, good. What we do is simply lay off the room area as if it were a Braille cell. Just for an example, I'll show you the way this table in front of you is set up. It's set up with 6 chairs arranged in 2 columns, just like 2 columns of 3, just like the Braille cell is. So if you would, why don't you just go around, check out the layout of this table, and then I'll continue. So that would be dot watt that we're at, that you're at, if I'm at the bottom of the cell here.
This would be dot 1.
Okay, good.